So now that we understood the benefit of dynamic BGP peering, we'll now look at how we can configure BGP peering dynamically to listen to multiple BGP neighbors and form neighbor relationship. So it's broken down into few simple steps. The first thing you do on the route reflector or the hub location router is to create a peer group. Once you define the peer group, you define the listen command. The listen command tells you how many BGP connections you are going to allow for this router to establish. So you say, I only want to allow this router to establish 500 BGP connections. So you specify the command BGP listen limit 500. Remember, the default limit is 100, so you don't need to specify the command, but any configuration for neighbors above 100 neighbors on the router, you will require to specify the limit command to listen for the BGP connections. Once you have defined the limit, the next step is you define the subnet or address range for which you will be establishing the connections. So in that, you actually assign that subnet range to the peer group. Once you have done that, the next step is assign the AS numbers. So you define what is the AS number for the connection, and you also use the alternate AS command, which uses options for specifying 4 other AS numbers apart from the AS number specified in the command itself. So this makes total of 5 AS numbers that you can specify, and once you have done all these steps, now you can go ahead and activate the peer group. This makes the configuration fairly simple, and in just 4 or 5 lines of configuration, you can actually allow up to 5,000 BGP neighbor relationship configurations. Let's look at the configuration now. In this configuration, the first step is we define the peer group named test. We then define the listen limit for the BGP connections to 300. The third step was to assign a net or address range. So what we did was we specified BGP listen range and specified the subnet mask of 192.168.0.0/16, and we assigned it to the peer group test that we created above. The next step was to assign an AS number for the peer group. But now we are not just assigning one AS number, but we are assigning multiple AS numbers. So you are using the alternate AS command. Neighbor, name of the peer group, remote AS, AS number, alternate AS, and rest of the 4 AS numbers that you want to specify. It is not mandatory. You have to specify all the rest of the 4 AS numbers, but you can specify as it's an optional configuration. Once this is done, you go into the address family and you activate the peer group test. Let's now look at the configuration on the live router. So we have routers in this topology, 4 routers, which are R1, R2, R3, and R4. Router 1 is where we will be configuring dynamic BGP peering. Router 2, Router 3, and Router 4 are in different ASs. Say Router 2 is an AS200, Router 3 is an AS300, Router 4 is an AS400. And we are keeping the Router 1 as part of AS100. Now if you notice on the router, the first thing to verify is what are the interfaces. So notice that all the interfaces that we are trying to establish the eBGP peering on are part of the common subnet 10.1.0.0/16. Well, you found a subnet range that you can specify for establishing BGP neighbor relationship. So let's now configure dynamic BGP peering. We go into the config mode and we say router BGP 100. If you want, you can specify the router ID, but it's not mandatory. Then you define the peer group, neighbor test peer group. Once you have defined the peer group, the next step was to specify the limit of the BGP connections that you're going to listen. BGP listen, and let's see the options. We have 2 options, limit and range. In the limit command, we specify how many numbers we want to limit. Though it's showing an option for 10,000 max number, but remember, you always have to verify what is the maximum number of BGP peerings that are supported on the router. So it's better before you configure any maximum limit, you verify the platform data sheet and see what are the maximum number of BGP neighbor peering that are supported on the router itself. So here we specify the limit as 1,000. Then the next step is we specify the subnet and address range. So we specify BGP listen. Now we use the range option. and we specify 10.1.0.0/25/16 peer group and assign it to the peer group test. It has been fairly 4 steps so far: configuring or enabling the router BGP process, creating the peer group, specifying the BGP listen limit, and specifying the subnet or address range. The next step is to assign an AS number for the peer group, on which it will be forming neighborships. So we specify neighbor test remote AS 200 and specify the alternate AS options. So here we have, so now we assign the AS numbers to the peer group. So neighbor test remote AS 200, alternate AS 300, and we do a question mark, we still get an option. So we specify 400. So now we will be listening to BGP connections for the subnet 10.1.0.0/16, which are coming from AS numbers 200, 300, and 400. Now, since we have done that, what we can do is go ahead and specify address family IPv4 unicast and activate the peer group. So neighbor test activate, and we are done. Now the hub location devices only need to configure the peering or specify the peering IP of the hub location router, and they are done. They don't need to specify any separate configuration like it is required for dynamic BGP peering on the hub location devices. So here we go. We go into the config mode and say router BGP 200, neighbor 10.1.12.1, remote AS 100. So now that we have neighborship established between R1 and R2, we'll go ahead and configure router 3 and router 4. So on router 3, we go ahead and say router BGP 300, neighbor 10.1.13.3, 13.1, remote AS 100. Address family IPv4 unicast, neighbor 10.1.13.1, activate. We are done here. Now we move on to neighbor 4. Router BGP 400, neighbor 10.1.14.1, remote AS 100, address family IPv4 unicast, neighbor 10.1.14.1, activate. And we are done. So this completes the configuration for dynamic BGP peering between the hub and the spoke location. Notice that we have to kind of repeat the similar configuration on the spoke sides. So if you had a peering with a common loopback address, then you wouldn't need to specify different IP addresses for establishing the peering. You can specify or kind of copy paste the whole configuration on router 2 and router 3, router 4. Whereas on router 1, you only had to do 5 lines of configuration, which got the stuff working for us. So show run pipe section router BGP. So if you notice, there are only few steps that are required to establish 1000 BGP connections.